Let's do this question, students. So we got a circle and there is a tangent that is hitting the circle, and we got from the center we have an intersection there, and then we got a chord that is actually going up from here. Right, from this point there is a chord, and there is another chord, and then there is a connectivity there. So this point is O, and let me write down the statement for this particular question. B, C, D are points on the circumference of the circle, and the center is at O. Now ABO is a straight line, and AD is the tangent at D. So what I will do is I will stretch this tangent. I'll just say AP is the tangent at D, and we have an angle. The angle DAO is given to be as 40 degrees, and we are asked to find BCD. Now let me mark these spots. So BCD, they are points on the circumference. So you got a B here, and you have a C here, and you got a D here, and this is going to be A, and this point is going to be P, right? And you are expected to find BCD. It's also given that DAO is 40 degrees. Okay, DAO is 40 degrees, and you are asked to solve this question. Okay, fair enough. So I hope you can pause the video and complete the solution for this question. Okay, so now that you got the answer for the question, foremost, as I always mention to you, observe the figure for tangent radius connectivity. So there is a radius and there is a tangent, and clearly this angle is 90 degrees, right? The angle between the tangent and the radius is 90 degrees. So this is 90, this is 40. So what would this be, right? So let me write the solution. Angle A plus angle D plus angle at O is equal to 180 degrees. So angle at A is 40 degrees, and angle at D is 90, and we need angle at O. So this is going to be angle at O is equal to 180 negative 130 is equal to 50 degrees. So central angle, right? This is the central angle. This is 50 degrees. We've got the central angle. So now the question is, we are expected to find BCD, right? Now we are going to use an important rule here, right? We are not able to use this 50 degrees. Now, why we are not able to use this 50 degrees? Of course, because of the fact that there is no real connectivity between the central angle and the angle at the circumference, right? Because the central angle, if we were to draw, the central angle is connected with the inscribed angle. So this is the connectivity that the central angle will have. Right? If this point is some t, I can very well get the angle at this particular point because this is an inscribed angle and there is a connectivity between the central angle and inscribed angle. But we have to get BCD. So this is the angle at the circumference. So there is a rule. Now clearly you can see this is the angle at the center. Okay, so the rule is I'm going to utilize the connectivity between the angle at the center and the angle at the circumference. So we know that. What do we know? Angle at the center, I'm stating it, is equal to 2 times the angle at the circumference, BCD. So this is an important formula. Now angle at the center, what is the angle at the center? The total angle is 360 degrees, right? And I have to take away 50 degrees. So if I were to take away 50 degrees, I would get 310 degrees. So write that down. So 310 is equal to 2 times angle BCD. So let me use this particular space here. I'm going to rewrite this. 2 times BCD is equal to 310. So therefore BCD is equal to 310 divided by 2. So how much would that be? 2 divides 3 one time and I've got to carry out the 1. That's going to be 11. 2 divides 11 5 times, right? And the 1 gets carried and I get another 5. 155 degrees is the answer. So probably you can write here. So therefore angle BCD, this is the angle we need, right? BCD is equal to 155 degrees. And probably if you want, you can draw a double line and give some light shades, right? So that is a solution for that question. Students, will move on to the next one.